So, hi, ladies and gentlemen. Hope you all are fit and healthy today. Thank you for joining us today in a webinar on disaster recovery and resilience on AWS Cloud. I would like to welcome today's speaker, Mr. Doug Newman, who is the CEO and the co-founder of a company called Arpio. If I talk about Doug, Doug is a veteran of cloud and having 10 plus years of experience in the cloud space. He was previously associated with Microsoft and leading a team of software engineers of Microsoft and created the first SaaS-based product under Microsoft, which is known by AWS, which is known by Azure DevOps, I think nowadays. Even he was leading a team of software engineers and development team in bandwidth encryption, and their infrastructure was running on AWS cloud. And as far as Doug is concerned, they hit with a disaster on AWS cloud and they faced a huge data loss at that front, which led them to innovate a solution called RPO. So we all thankful whosoever have joined today on the webinar. From this, I'm handing over this webinar as a speaker to Mr. Doug to give us some more insight on that. Over to you, Doug.
Great, thanks, Akash. I really appreciate the intro. And thanks to all of you who are joining us today. We've got a very global audience here, and especially for those of you for whom this is maybe evening time on a Friday and you're beginning your weekend with a talk about disaster resilience and recovery for AWS. We appreciate you sharing your weekend time with us. I'm joined today by my colleague, Shaw Terwilliger. Shaw is going to man the Q&A here in the webinar. And so as you have questions, we encourage you to ask those questions in the Q&A. Shaw will answer those for you, and he will interrupt me and escalate some questions as appropriate if he thinks it's something that we should be talking about overall. But without further ado, let's talk about what we're going to talk about. Today's goal is to help you understand and assess and eliminate the risks of significant downtime within AWS for your AWS workloads. And we're going to spend a lot of time kind of contrasting cloud risks and cloud systems, cloud solutions from what you might be familiar with in more traditional on-premises environments, just to help us to really understand how it is that we address these in AWS. Before we dive in on what we're going to learn here, I wanted to start today by sharing with you guys a few stories of significant outages, catastrophic downtime in AWS. So the first story that I'm going to share with you guys today has actually been in the news really recently here in the United States because it's going through the federal court system right now and being prosecuted as a criminal act. This is a story about Sudheesh Kasaba Ramesh, who was an employee of Cisco WebEx and left Cisco WebEx in the spring of 2018 and apparently was pretty unhappy with the experience that he'd had there. Several months later, he realized that he still had access to the production AWS environment, and he took it upon himself to connect to that environment and to delete 456 virtual servers that were supporting the WebEx Teams application. Now, you can imagine losing 456 servers all of a sudden is a pretty catastrophic event. And it took Cisco 2 weeks to recover their service after this. They had 16,000 customers who were impacted by it. And at the end, their analysis says it was a $2.4 million hit to their business between the employee costs to recover as well as the penalties they had to pay out to their customers for the downtime. You can imagine it was probably even more valuable if you consider the brand reputation that took a hit as part of this event. So the second story I want to tell you about is we call it Murder in the AWS Cloud. That's actually not our title. That came from this InfoWorld article. But this is a story about a company called CodeSpaces. CodeSpaces was once upon a time an up-and-coming competitor to Microsoft GitHub. And they had made a name for themselves providing source control and project management for development teams within regulated environments where data protection is paramount. They had a fantastic program. They heralded their program around backups and testing backups to make sure that they were resilient to all kinds of data loss events. Well, one day, CodeSpaces woke up and found that their service was under attack by a distributed denial of service attack. And in troubleshooting that, they logged into the AWS console, and they found buried inside of the AWS console a ransom note demanding money to cease the attack. Now, what should be going through your head at this point is that somehow the attackers had gotten into their AWS accounts so that they could leave this ransom note. And Codespaces did what any of us would do and said, well, we need to go lock these people out, get them out of here. So they started to shut down whatever access had been taken advantage of here. Unfortunately, the attackers recognized their defensive acts, and they responded by just beginning to delete servers, backups, buckets, all of the data that they could access within that AWS account. And they essentially deleted all the meaningful data that Codespaces had and all the backups that they had of this environment. Within a couple days, Codespaces had to alert their board, their employees, and their customers that they were going out of business. They couldn't recover from this catastrophic event. The last story to share with you guys today is a story from earlier this year when the Sydney region of AWS suffered a 7.5-hour outage of the VPC service. Now, if you know AWS, you know that the VPC service underpins most of the networking that happens within AWS. And when the VPC service is not available, all kinds of problems ensue. This particular outage was caused by the failure of the database system that underlies the VPC service. And the primary node of this database system was lost. They had to restore it from backups and able to recover the service. And that's what took so long. The outage itself cascaded well beyond the VPC service. So all kinds of compute services, the Lambda service, anything pretty much that relied on the VPC service for updating network configurations and scaling and things like that were unusable for the better part of the day in Sydney that day. And so with those three services as backdrops, we want to talk about a few lessons to learn and things that we should know as we're evaluating our risk and how we mitigate that risk within AWS. And the first thing I want to talk about today is that most failures in the cloud are logical failures and not physical failures. So to really understand what we mean by that, let's talk about the difference between these two. Physical failures are quite simply failures of things that you can touch. So these are typically the kinds of disasters that we've looked to mitigate with on-premises workloads for years. So everything from hardware failures, which we're pretty good at mitigating these days, to power outages to data centers, fires, floods within data centers, cooling fails within data centers periodically, and the temperatures rise and the hardware shuts down. And we often think of these physical failures in the context of natural disasters. How would we respond to a cyclone, a hurricane, an earthquake, a tornado striking our data center? And how is it that we maintain redundancy around that? Well, if you think about the three stories we just told you, none of those issues were physical failures. Those are all what we consider logical failures. Logical failures are things like cyber attack, ransomware, insider threats like that Cisco outage we talked about, other compromises of your environment. They're also just human error. Some of the most famous outages of AWS have been Amazon employees making mistakes that have brought down significant services. And if you think about, as a great example, in 2016, the S3 service in Northern Virginia went down, brought down most of the Northern Virginia region as part of that. And that was because an employee had made a typo in performing a maintenance operation and accidentally shut down significantly more servers than they were supposed to. The other kinds of things, that's actually a good example, and the Sydney, Australia story is a really good example of failures in shared infrastructure within AWS, and the failure of those bringing down systems based on those. And these failures may happen at the AWS layer, which is oftentimes what people are thinking about when they're thinking about recovery, is how do I react to Amazon having an outage. But they also may happen at your layer, which is really what happens with things like insider threats and ransomware and stuff like that. So how do we solve for these? Well, the first thing, and if you think about that code spaces story that I told you about, if there's only one thing you take out of this webinar today, I hope it's this. It's that you need to lock down your backups so that if you have some sort of compromise of your system, your backups are not exposed to the attacker who has compromised your system. And so typically we do that. You do that in AWS by taking your backups and either moving them out of AWS entirely or moving those into a different AWS account. And that AWS account, you can keep completely locked down so that nobody has access to it. It's not susceptible to the same attack vectors as your production environment is. The second thing that we do here is to ensure that you can recover your service into a secure environment. If your environment has been compromised, you may not, actually it can be extremely difficult to figure out all the attack vectors that have been opened up as part of that compromise. And so you don't want to restore your service within that same environment. You need the ability to recover it within another environment that you have extreme security controls over, and ideally is not susceptible to whatever attack vector has allowed an attacker within your production environment. And then the third thing here is you need the ability to recover to alternate infrastructure. If your AWS infrastructure is down, if the VPC service is lost in your region, you need some ability to resume service on top of a different redundant infrastructure. And that is a good segue to the second lesson that we want to talk about today. And the lesson here is that multi-region AWS is about infrastructure diversity just as much as it's about global redundancy. To understand this, we really need to talk a little bit about the architecture of AWS, just to make sure that everybody's on the same page about this. Amazon operates AWS in 24 distinct regions around the world. And each of those regions are composed or comprised of 2 or more, I think it's actually at this point 3 or more in all regions, individual availability zones. An availability zone is a fault zone within a region. It's actually, you can think of it as distinct data centers that Amazon is operating within this region. Oftentimes, availability zones are well more than just one data center. But the idea here is that if you deploy your workloads across multiple availability zones, then you're resilient to the types of outages that could impact an availability zone. And those outages are really the kinds of outages that would impact a data center in an on-premises way. So if you think back to our physical versus logical distinction, that's a good way to protect yourself from network outages to the data center, power outages, floods and fires that can happen within data centers. But availability zones are only partially isolated from each other. And there is a significant amount of shared infrastructure within an AWS region. And the VPC service that failed in Sydney is a really good example of this. In order to be resilient to an outage of that shared service within a region, in AWS, you have to architect your workload to be able to run in multiple regions or to transition to fail over to an alternate region. And so most people think when they're considering their deployment and they're thinking about their disaster risk that we would need to use multiple regions if we have a business requirement that says we need to have our environments separated by a great distance. Availability zones are typically separated by miles, few miles, whereas regions are separated by hundreds of miles. And I'll use kilometers and hundreds of kilometers since I know this is a very international audience. But multiple region architectures are also about protecting yourselves from failure in shared infrastructure within a region. And in order to be resilient to those outages, which are really the outages that happen, it's very rare that you have an earthquake take out an entire region of AWS. But it's not rare that we have region-wide outages of shared infrastructure services that can last for many hours, like what happened in Sydney, Australia. So the whole point here is when you're considering your risks and how you mitigate those risks, you need to consider using multiple regions, not because you have a business requirement about having great distribution between your data centers, but rather because you have a requirement to be resilient to infrastructure failures that can happen within a single region. The third lesson here to take away is really that your cloud workloads are different than on-prem workloads. And therefore, the way we mitigate these risks in the cloud is going to look different from the way it looks for on-premises workloads. So if you think about a typical on-premises data center, you really have three core services in an on-premises data center. There's the network that connects everything together, there's the storage where all of the data lives, and there is the compute, which these days is almost entirely virtualized on platforms like VMware. These things are more and more converging into hyper-converged architectures, which means that we can oftentimes mitigate these disaster risks in our on-premises data center by just implementing a solution at the platform layer. We can use a SAN solution for storage that can be replicated to a different location hundreds of miles away. We can use a virtualization solution for our compute that similarly could be replicated to another data center or could be replicated into the cloud so that we can continue operating our services there, which makes for a nice clean layer where we can plug in resilience solutions to ensure that we can recover from any kind of outage. Contrast that though with what you have in AWS. Nobody can count how many services there are in AWS. It just depends on how you define a service. But there's at least 200 distinct services within AWS. That's at least 14 different types of compute, 17 different types of storage across object storage and different database platforms and block storage. Each of these different services have a different story to tell around how you build resilience and how you would be able to recover from an outage for that particular service. So the things that we need to learn about here is that in the cloud, it's critical that we capture the complexity of our environments in automation. And this is something that is well-known best practice that we automate our cloud environments. But unfortunately, it can be extremely difficult to achieve. And especially if you didn't start with this from the very beginning, it can be really challenging to engineer automation then on top of it and to give yourself the resilience solution that you truly need in order to be able to replicate these complex cloud environments. The next thing, though, is that restoration, that automation, it needs to consider data restoration as part of the plan here. So most people who are investing in automation for their cloud environments are thinking about how do I spin up new environments, clean environments. But in the event of a recovery, we actually need an environment that also restores the data that we have. And so we need to invest with our automation in being able to plug in the data into that automation and restore our data from backups as part of that automation solution, which is typically not accommodated for. And then the last part of this is that it's absolutely critical to test recovery. Cloud systems are complex. I know I personally have never built a complex system that just worked the first time. If you aren't testing your recovery process and retesting it periodically as your environment is evolving, you can't know that it's going to work for you. You can't be confident that you've truly captured all that complexity and all of the data and have the ability to restore. It's pretty common that businesses for decades have had a practice around, we do a test every 12 months or so, once a year, because it's required as part of our audits. But in the cloud world, things are moving more quickly, and I'm sorry, I just got a little feedback that maybe my microphone isn't working terribly well here, and I'm sorry if that's the case. I'm not really sure how to deal with that. I do have a headset that I can go ahead and plug in, and we'll try that if it continues to be a problem. So I'm sorry about that. All that said, though, you need to test your recoveries periodically and make sure that you're able to restore these environments. So another way that is commonly looked at is you have two different types of risks that you need to mitigate in your environment. There are cyber risks. And the way we mitigate these cyber risks is by having the ability to fail over our AWS environments into a locked down environment. And in that locked down environment, we have staged a history of recent backups, so that if our cyber attack is something that corrupts or deletes data, and that corruption or deletion should get replicated to our recovery environment, we have prior backups that we can apply that don't include that corruption, which is exactly what you need in the case of ransomware, as an example. The other types of risks that you need to mitigate are infrastructure risks. These are partially mitigated if you're using multiple availability zones within a region. But to comprehensively mitigate these, you need the ability to fail over your workload from your production region into an alternate region. So combining these two things together, you need cross-account failover, cross-region failover, and you need to keep that recovery environment completely locked down. Now, these are hard problems to solve. And these are also problems that for many businesses, while they're important, they're not strategic, and it is difficult to consider the trade-off between making customers happier with new functionality and winning new business with new investments versus mitigating these risks. And that's really why we have built Arpio. Arpio is a disaster recovery and outage recovery solution for AWS workloads. And what we've done with Arpio is built platform layer capabilities to protect your AWS environments from any outage so that you can quickly recover in 10 minutes or less from any outage in AWS. So that starts with global redundancy, the ability to easily move your workload out of your production region into a recovery region and continue operating your business over there, which means Arpio can take your infrastructure as well as your data and recreate that in just a few minutes in a different region. It also involves protecting that data in a lockdown environment. And for that, Arpio gives you the ability to recreate that environment in a different AWS account that you keep locked down. Only Arpio and a couple people at the top of your organization really need access to that environment, so you can keep it completely locked down and not expose it to the same attack vectors that a hacker might use to get into, or an insider threat might use to get into your production environment. Automation is key to all this, as we already talked about. And Arpio fully automates both the backup process as well as the recovery process. Arpio can recover your environment whether or not you are using existing automation solutions. So a lot of you may be using tools like Terraform or CloudFormation, but many of you might not be using them. And those who are using them might be on a journey to comprehensive automation. Arpio doesn't care. It can replicate your environment whether or not you've used these kinds of technologies to create the environment in the first place. And lastly, Arpio focuses significantly on ensuring that the maintaining a recovery environment in AWS does not need to cost you a lot of money. Arpio is extremely lean on how it uses AWS on your behalf, and therefore it can really minimize the cost of maintaining that recovery environment. Our customers typically tell us that their recovery environment costs less than 1% of their production environment. All you have to pay for with Arpio is some data transfer and data storage until you need to use the environment and bring it up. So I've got a little demo here that I want to show you guys. Actually, before I jump in, let me show you what the demo environment looks like. We've got two applications running in our demo environment here. The first is sort of a cloud forward auto scaling application. It's got load balancers in front of it. The compute runs in EC2 for this particular workload, but it is auto scaling. And we use RDS MySQL in this particular case as the backend. This workload is running in the Northern Virginia region and is distributed across 2 availability zones within that region. The other workload that we've set up here is a little bit more traditional enterprise workload. It's Windows servers running in the same AWS account, actually. And this is actually just Amazon's Active Directory quick start. So if you needed to spin up a typical AWS or a typical Active Directory environment in AWS, you might use this very same quick start to bring up that environment. What's really important to understand, though, as we look at this, is that RPO handles not just the data, but the entire environment. So it deals with all of the nitty-gritty details of things like security groups and making sure all the security group rules get set up correctly, route tables and make sure all the routes point at the right endpoints, IAM policies and roles, and making sure the right permissions are granted to the right entities in order to run your stuff. RPO will recreate your entire network, all of your security settings, monitoring and CloudWatch, identity and IAM, caching in services like Elasticache, and make it really easy for you to recover your environment in the event of an outage. So now I'm going to just quickly transition over and show you a quick view of what this looks like over here. And the first thing to understand is that RPO handles outage recovery at the application layer. So we're going to set up recovery for the set of resources that participate together in our workload here. Every workload has a name. I'm not going to be very creative here, and I'm just going to call it the RPO Demo workload. And then I have a scratch pad that I keep that has my AWS account IDs on it. And I just need to tell RPO where in the AWS world this workload runs. And so it's in this account in Northern Virginia. And I want to be able to recover that into a different account. This is the account that I keep locked down. It's my bunker account, my vault. And I want to set this one up to run in Northern California for the demo here. So I tell RPO about the location of my workload and where I want to be able to recover it to. RPO is going to go out now and validate that it can check, that it can connect to these environments, and we'll be able to do its work. Now, RPO is a SaaS product, so there's nothing for you to install in your environment, and there's no agents for you to run on your EC2 instances. We work by connecting to your environment and using the AWS API to manage things, to manage this recovery process for you within your accounts. We have limited access to your account. We've done a lot of work to lock that down, and your data never leaves your accounts. RPO doesn't even have permission to take it out of your accounts. So all we're going to do is be moving the data around as you've configured here. And the very last thing I need to do after RPO is connected is just to tell it what resources matter. So I can come in here and I can do that by tag and say, I want everything that has the environment tag with the value of the Digitata AD domain. And you'll see that picked up these 3 EC2 instances. But as I scroll down, you'll see RPO also knows that those instances have elastic IPs on them. And they live in a network with this DHCP configuration. And here's the internet gateways, the NAT gateways, network ACLs, route tables, all of that network stuff that you need to recreate your environment, RPO can handle for you. The security settings also RPO picks up as part of this. And you'll see down here, RPO also has discovered IAM roles that live behind instance profiles that are assigned to those EC2 instances. So the thing to understand here is that RPO, when you just pointed at one resource within your AWS environment, it's able to go and discover the entire ecosystem within AWS that's necessary to recreate that entire workload behind that. This is actually better demoed if I don't use tags. And I just kind of say, I just want this load balancer. And you'll see here that load balancer, RPO knows it points at an auto-scaling group. And the load balancer needs this SSL certificate. And the auto-scaling group uses this launch template. And the launch template references this EC2 image. And so Arpio is going to go and capture everything necessary to be able to recreate that environment in the event of an outage. For this particular workload, I need the load balancer and everything behind it. I also need the RDS database. And when I select the RDS database, Arpio knows that there are parameter groups, subnet groups, and option groups that need to be included in this recovery process. But that's all that it took for me to set up cross-region, cross-account disaster recovery, outage recovery for this canonical AWS workload. And you'll see here over the next few minutes, Arpio is going to wake up and start the process of replicating that environment. The first replication will probably take about 10 minutes with this particular workload, but all subsequent replications are incremental. So it only has to move the churn, things that have changed, and therefore they happen a lot faster as part of that.
Hey, Doug, I think it's a perfect time to answer a few questions we've got stacked up.
Thanks, John. Okay.
Yeah, no, actually one's very timely. We had a question, is Arpio discovering the resources automatically? And I think you just covered that as the question came in.
Yeah, Arpio does go and discover, it connects to your environment, lists all the resources, and it discovers the dependencies. And therefore, when you choose one resource, Arpio knows what all the supporting resources are that also need to get selected as part of that.
And that's really dynamic over time too, right?
Yeah, and it is dynamic over time. As your environment evolves, Arpio will continue to recompute those dependencies and pick up new resources that need to be included in that.
Great. So a couple more questions. We had a question about support for VMware on AWS and also AWS to Azure recovery.
Yeah, so those are great questions. They come up very often. We do not yet support VMware on AWS. That's actually not a question that we get asked very frequently, but it is something, our vision for Arpio is to be able to support all of the compute platforms. And so if that were something that a customer were really interested in, we certainly would be able to go in and take a look at whether we could satisfy that. As far as AWS to Azure recovery goes, that is on our roadmap, but that's a longer term thing. Our philosophy for our product today is that we want to do a great job of high fidelity recovery within a cloud platform. So we support AWS today. Azure will support within Azure cross-region and cross-account failover in the near future. And eventually, we believe that there might be a reasonable place for us to be doing cross-cloud recoveries. But that also might be built on top of abstraction layers like Kubernetes that are becoming very popular and give a really nice ability to be platform agnostic in the applications that you're building.
Well, that's a perfect segue to the next question I'll select, which is, does Arpio work right now with EKS clusters?
Yeah, so Arpio, we are releasing support for ECS next month, just a few weeks from now, and then EKS will come right after that. So we envision that Arpio will support EKS disaster recovery in the beginning of 2021.
Great. So I have a question here about Oracle databases. The question is that Oracle uses DataGuard to do replication. Sure. How does Arpio do it in AWS for databases?
Yes, so Arpio uses platform layer capabilities to do replication. So we are not using anything at the database application layer, which has the advantage of it's very easy to configure. You don't need to go set up separate recovery solutions for the database from everything else in your environment. Arpio handles all of that for you at the platform layer. Depending on how you're running Oracle in AWS, then we're doing various different things. But if you're running it on EC2, today, Arpio is creating snapshots of your Oracle database server and replicating those snapshots over into your recovery environment.
Okay, and then another question, are we using DMS under the hood for the replication? And I think you just mentioned that we're using a snapshot strategy.
Yeah, we're using snapshots it depends on the service. So the whole point of Arpio is that every service has a different story to tell about how you would do this replication. We are not using DMS in any cases currently, but the way you do this for EC2 looks different than the way you do it for RDS, which looks different than the way you do it for, let's say, Elasticache, or the way you would do for Redshift. So every service within AWS has a different capability here, and it's Arpio's job to go figure out the right way to do that and put together a cohesive solution for you.
Man, Doug, I've just got so many more queued up. Actually, just a couple more, but
okay,
seems like a good time while we're staging this recovery point. We got a question. What is the minimum RTO for RDS in your DR region? Does your software promote the slave to master without manual intervention?
Yeah, okay, so the RTO is a function of how quickly Amazon can do the orchestration that's necessary. Today with RDS, we use snapshots to capture your database, and then we have to launch a new database in your recovery region, which with RDS, it's going to depend on the behavior of AWS at that point in time. It can be somewhat varied, and it also depends on how large your database is. This one that I'm standing up here takes about 5 minutes to recover the database in the other region. That said, we have on the roadmap the ability to use a read replica in the recovery region and automatically promote that read replica for you in the event of an outage. And that would give you an even faster recovery time objective, as well as a better recovery point objective. But that comes at the cost of you now have to pay for additional resources. And so you have to make the decision of whether you want to run another RDS instance in your recovery environment, or have that be a cold standby that Arpio can bring up in just a few minutes for you.
Great, just a couple more have come in. Thanks everyone for these questions. These are some great questions. Let's see, what kind of security scenarios does your company bring in on top of AWS security infrastructure? So I think that's sort of in the how does Arpio help me get better security kind of realm.
Yeah, so I think there's probably a couple layers to that question. Security is always layered. The first is that Arpio makes it easy for you to do the AWS best practices around security, which is to maintain your data backups locked down in an alternate AWS account. So you can go and do that yourself if you want to build your own automation for it, but Arpio makes it really easy to do that. So to some extent, it's giving you additional security just because it's making it easy for you to do the things Amazon would advocate that you do. The next thing is really in how Arpio uses AWS to work within your environment. And so we've done a tremendous amount of work to lock down the access, minimize the access that we need in our customers' environments in order to do this work for them. And so that starts with just IAM and the way we craft the IAM roles and profiles that you need to install within your environment so that we can do that work. You have control over what Arpio can do within your environment based on those IAM things that we give you. But one of the things that we did to really differentiate was there were several scenarios that we were unable to use IAM to lock down at the level we felt was appropriate. And a great example of this is with IAM, you can lock down the ability to share snapshots with another account, but you can't lock down which account you share them with. And that would mean that Arpio would need the permission in your account to share it with whatever, and potentially become an exfiltration vector for you, which is not something that we want to be and not something you want us to be. So we, instead of using IAM to lock that down, we came up with another solution that involves installing within your account a Lambda that does additional controls, additional security checks that IAM can't do for you. And Arpio doesn't have the ability to call certain APIs, but instead has the ability to invoke a Lambda that does additional security checks that IAM doesn't have built into it. That's kind of getting in the security weeds. Would love to have an offline conversation with you guys about this.
Great. I think coincidentally that answered a few questions. One was, how do we connect to instances in private subnets that are locked down? Do we use keys and roles? And you just explained that we use the IAM role to access your account with limited permissions, and additionally the Lambda to scope it even farther down. Another question that came in is the backup location immutable?
Yeah, so we use snapshots for EC2 /EBS and RDS today. And those snapshots are immutable within AWS. They can be deleted, but they can't be changed.
Great. And one final question right now. Does Arpio help with active-active DR for there to be little or no downtime?
Yeah, so really, that's a great question. And active-active, we differentiate DR from high availability and put active-active in the high availability scenario. So unfortunately, active-active is something that has to be architected into your workload from the very beginning. We actually did a webinar about that a couple months ago. And if you'd like to learn more about that, get in touch with us, because I'd be happy to share with you the recording of that. We've got a pattern. We built Arpio itself is an active workload that runs redundantly across 3 regions in AWS. And so in building out Arpio and in helping other customers solve these problems, we've come up with a nice pattern for how you need to think about multi-region and active versus cross-region failover. But unfortunately, Arpio can't magically make your application multi-region active. You have to build that in from the very beginning.
Okay, I think that's worked through most of the queue there. So if you've got more to present, that's great. Otherwise, I think they're coming in slowly. So
well, let me just show really quickly. Before we started the demo today, I set up the exact same resources that we just configured, failing over to a different region. This is failing over to the Oregon region. And you can see down here, we've got in the primary resource column, these are all those resources that were selected when I checked that load balancer and I checked that database. And you can see over on the recovery resource side, there are replicas of most of those resources. And this is Arpio creating the recovery environment early on if the items that are in the recovery environment don't cost you any money. So this gives you the ability to now go in and make customizations as necessary to the recovery environment. But what's most important is that you aren't paying for things like a load balancer here, or you're not paying for this RDS database because you don't need it currently. You're not using your recovery environment. So why pay Amazon for that? In order to launch that, though, you can choose the test button or launch recovery button, depending on the scenario you're doing. I'll launch a test really quickly. And I can test individual applications. I've got 2 set up that go to the Oregon region here. And then I can choose which recovery point I want to apply. So if I had a ransomware attack, I needed to roll back to a historical recovery point, I could do that as part of this process here. I'm just going to go ahead and hit test recovery. And Arpio is now going to go through the process of reconfiguring that recovery environment and launching those servers, databases, load balancers, NAT gateways, Elasticache nodes, anything that Amazon would charge you money for so that you didn't have to pay for it before we actually needed it.
Great. While these come up, Doug, I want to forward you a question. I've had this multiple times, just so everyone can hear it. It's, will there be a recording of this available?
Yeah, we'll definitely record it. And hopefully we can figure out if there were any audio issues earlier on. I apologize for whatever problems people are having. Hopefully that doesn't show up in the recording. And if it does, we'll figure out how to make a new audio recording for you.
Yeah, the audio has been good for me. So I think if anyone missed out because of some transient issues, the recording should be solid. Let's hope that it's
great.
Clear.
All right. Well, that, guys, is pretty much the demo. Arpio is going to come up. It's going to take about 5 minutes for this workload to come up. And after a few minutes, we'll be able to go in and hit the load balancer, and you'll be able to see that this application running in Oregon is now up and running. And one of the things that is really important to understand here is the application wasn't built in any special way to be able to work with Arpio here. Arpio created a replica environment in Oregon that was identical to the environment that we had in Northern Virginia, so that the application is none the wiser. It doesn't even realize that it's running there. And that it means things like all the IP addresses of all the servers have been preserved. The private IP addresses have been preserved. So configuration where servers are talking to each other by IP hasn't changed. We even go so far as for your RDS database that in the Northern Virginia region, we connect to it with a host name that says US East 1. That's the Northern Virginia region's code name. Well, when we move that over to Oregon, that RDS database gets a different host name that has US West 2 in it. And if your application is looking for US East 1, it's not going to find it in Oregon, except that Arpio created a DNS alias for you so that that US East 1 host name resolves to the US West 2 IP addresses, and your application is still able to work and connect to that database. So really important to understand that, that you don't have to do anything special within your applications to get it to work with Arpio. The environment we've created is identical to what you had in your production region. So I'm going to go ahead and just sort of wrap up here. And if people want to stick around, we can hit that load balancer here in a second and see if it's passing its health checks, which really means that the database is up and responding, and therefore the application is able to pass its health checks. But really appreciate you guys sharing some time with us today. I hope that you've learned something here, and we will follow up with the slides and a recording. We would love to chat with you further and share more about disaster resilience in AWS. We encourage you to check us out on LinkedIn, get connected so that we can just be part of your social professional media flow. So, all right, Shaw, any other questions that we need to field before we adjourn here?
Nothing queued up right now. If you've got one, drop it in just at the last minute.
Okay.
I did answer a few questions privately. Just encouraging people, drop us an email. You can reach us at info@rpo.io or Doug@rpo.io or Shaw@rpo.io. If you've got any questions about service support, or you'd just like to share your thoughts about what's important to you and your organization.
Yeah. So really quickly, the RDS instance is still coming up, but you guys probably know RDS launches the database and then goes through a process of backing it up and various things. So oftentimes it's responsive before it's completely up. And we'll just hit this here, and it's not up yet apparently, because the health checks aren't passing and we're getting 503 error. But in a minute or two, we'll be able to refresh this page and you'll see the website running behind it. So thank you all for sharing some time. If you have any questions, please reach out to us. We'll follow up with some email communication, getting you this content. And I hope it's been valuable for you. Thanks a lot. And hit refresh here and see if it's working yet. Ah, there it is. Okay, I hope you didn't hang up before that. I was just about
perfect
30 seconds early. So, all right, thanks guys. Have a great weekend.
Thanks everyone.